Okay, good morning. This is Professor Grenfell's Math 12 Statistics class, continuing our lecture in Chapter 10 on uh, correlation and regression. And let's see, we're going to do a quick example right now. I could not get the video to link correctly, so I'll post it hopefully as a separate video. But all of the work I detailed in another video that will hopefully materialize one of these days. This video will detail how to, well, one method of utilizing a spreadsheet such as Excel, Numbers, where I use Google Sheets in order to speed up some of the calculations. And this is fine with me if you want to do this, as long as you send me the whole file and that is something that I can view your complete work, then that would be acceptable to you as well. So we're going to do example 10-5, and if I can manage to get all of my words out quickly and not have too many of them, then this is going to be a brief example because, like I said, I've used Google Sheets to speed up, to perform most of these calculations for me. And I'll just show you the results, essentially. So we're looking on page 555, and here it says to compute the value of the linear correlation coefficient, also known as the PPMC, for the data obtained in the study of the number of absences in the final grade of 7 students in the statistics class that was given in example 10-2. So the first thing that we were going to do there is to go ahead and create a table and record the data. So there we've got all that copied down correctly. So student A had absences, they got a 82 as their final percentage. And then what we remember is we have to insert some extra columns here. So I'll go ahead and kind of copy the style that the book does this. We'll do x times y, so we'll just take this value times this value and write it in. We'll create another column for x squared. I'll write it like this: x caret key 2. Okay, that is how we type exponents usually. You notice your calculator probably looks like that when you want to use higher exponents. And then similarly here, this is y squared, so y caret 2, right, is how we write that. We'll just remind us what these are. That's x squared, that's y squared. So this is the part where I used Google Sheets, the spreadsheet application, to fill in all of these values. So I wrote in a formula for this, and I just copied and pasted that so that it would do the whole thing every single time, just for these varying different values for the different rows. So the reason that we were doing this was so that we could get the sums for all of these columns, right? So that's the part that I'm going to just sort of quickly skip over. All right, so there all of those values are. So notice this first column, these were the x values. So there's the sum. So that first column is 57. That's the sum of the x's, and so on and so forth. So we have all of the sums of all of these columns because these are the quantities that we're going to then substitute into our formula for the correlation coefficient. So anytime you hear a vocabulary term, try to remember what symbol goes with that term. So here we're going to memorize, that's not a word, we're going to memorize that the correlation coefficient, the PPMC, we just denote that by R. So you hear a correlation coefficient, you're going to compute, that's right, R. And then try to write down the formula from the best of your memory. So there's our formula for R, that whole thing is. And so then what we're going to do is we're going to substitute in these values where they are meant to go. So here, the first thing we're going to plug in is 3745 in place of this value, and so on and so forth. So I'll just go ahead and fill in those values so you don't hear the pen tapping. And so there we have everything substituted in. I kind of tried to leave the original sums on the same page and color-coded a little bit so you can see where I got everything. Remember the 7, that was what we were substituting in place of lowercase n, that's the sample size. And then there's the rest of the calculations that we had already done, or I let the computer do for me, and we're plugging this all in. And notice, just for example, here, let's compare and contrast. So over here, this 579 right here, for example, that is the sum of x squared. All right. So what we had to do is remember what was going on in that column. That was where we were taking x squared. That was, we were taking each value in this row, in this column, I'm sorry, the x column, and squaring it and writing it in there. So we were squaring first and then adding everything up. That's this result. And when we were doing this computation over here, we added up all of the x values first. That's how we got that 57. And then afterward, then we have to remember to go ahead and square that. And essentially, well, basically these two better not be equal to one another. So what you put in here and what you put in here, those better be different, or I can practically guarantee that you messed it up somehow. All right. So let's continue on from there. So I basically just from here get out the calculator, plug in everything, and we round it to 3 decimal points, 3 digits past the decimal point. So that will become negative 0.944. So here we obtain a result that agrees with our scatter plot from example 10-2, namely that there appears to be a pretty strong negative linear correlation between the number of absences and their final grade. As we increase the number of absences, as we kind of expect, the y value, their final grade, starts to decrease, and that's the significance of the minus sign. The closer the number, the numerical value, the absolute value of that, in terms of the magnitude, how big that number is. Remember, this is always somewhere in between -1 and +1, so it's always going to be a decimal like this. The closer it is either to -1 if it's negative, or to +1 if it's positive, the closer the numerical part is to 1, means signifies the stronger that linear correlation is, and so thus it will be a better predictor of our expected value if we want to use this to project. Say, suppose our student had this many absences, what would we expect their final grade to be? So that's the purpose of doing this type of statistics. All right, and we'll close out this one here. We'll do the next example for 10-6 very similarly, in that I will have skipped all of the hard calculations, or not hard, but simply tedious calculations will be done using sheets, and hopefully a separate video on that to follow. Stay tuned. Bye.